All right, moving on to practice problem number 4, associated with sample problem C here in chapter 4. A soccer ball kicked with a force of 13.5 newtons accelerates, so that means that whatever value comes after that is going to be the acceleration, at 6.5 meters per second squared to the right. Again, here is a direction, What is the mass of the ball? What is the mass of the ball? Well, mass isn't going to have a direction scalar. I guess we don't need I guess we don't need direction for this particular one. So, let's check it out. So we're still using mathematical representation of Newton's second law, F is equal to ma. And in this particular problem, we're trying to solve for the mass. So I need to actually get m by itself on one side of the equal sign. Old school phrase right there. So I'm going to divide both sides by a. That way that cancels. And so I will be left with, write this a little bit prettier, mass is equal to force divided by acceleration. And we have both of those values. So force is 13.5 newtons, right? To the right, because that's the direction in which the soccer ball is accelerated, and so the force is being levied in that direction. Divided by 6.5 meters per second squared. Again, the acceleration is to the right. You see acceleration at this value to the right. And so what we see is directions cancel. You don't need to include a direction here on your answer for practice problem 4. So when I plug this in the calculator, I get this big old long thing here, and that's not what I'm going to report. That's far too many significant figures. So when I look at what the question's given me, I have 3 significant figures divided by something that has 2 significant figures. And so what that means is I need to round to this spot right here. Now the 7 right behind it tells me that I'm going to round that 0 up to 1. But I'm still only going to report 2 significant figures. So 2.1. Now let's talk about the units here. Remember that a Newton is really a derived unit that is a kilogram multiplied by meters per second squared. The reason this is important is because I'm dividing a Newton, which is this, by meters per second squared. So if I were to divide this by meters per second squared, which is what I'm doing in calculation, meters cancels with meters, per second squared cancels with per second squared, and so I'm really only left with the unit for mass, which is nifty because that's what I'm being asked to calculate. The mass of this soccer ball is 2.1 kilograms.